Welcome everybody to Today in Space. This is another segment of People of Science where we get to talk to people working in STEM, who STEM is a daily part of their lives. We learn a little bit about them, what starts the passion to get them on this path, and then what they're doing, and what they're doing today in the space industry, in science. Today, we get to talk to Steve Good, the Chief Commercial Officer of Ramon.Space. We get to talk about supercomputing in space and everything that's going on with them. So, Steve, welcome to the podcast.
Thank you for having me. I look forward to discussing what we're doing and space in general. Space is literally the next frontier, and there's a lot going on in space. So we're at the forefront of pushing the limits on what's possible.
Awesome. So let's start with you. Tell us a little bit about the person, Steve. What got you started in STEM?
I got into STEM because I saw math as the universal language across everyone and everything. And I really embraced physics as I was going through school. Physics is a way to explain what happens in our world, in our visual world, with force and mass and acceleration. And those two really came together in university when I was able to leverage my love of space being the new frontier. I remember back watching 2001: A Space Odyssey, and there's a lot of ties and a lot of elements that apply to what we're doing and where the industry is going. With spacecraft becoming more human, with humans relying more on technology as we push the frontiers forward. So I've always been a math geek. I like to joke that I was a mathlete in high school, which was cool back then. At least I thought it was. And then I embraced physics and learned that, hey, I can use math and physics to do satellite and space stuff. So that's what really got me into STEM. And I've really encouraged my kids, I have 3 kids, to get into STEM as well, because I really see math, science as being the one universal element. You combine those two together to bring us all together. So that's what got me into STEM in general.
I love that. I don't think we've had someone give a math explanation for that, but that's beautiful. It's true. Like when I didn't really see that until I went to school, and it was people from around the world all doing, in my case, engineering. And you learned bits and pieces from everyone, but everyone, the science, you could communicate with each other regardless of where you came from. So
That's right.
beautiful.
That's right.
That's beautiful. So let's talk about. Oh, well, first, was there anything like? Did you find math on your own? Was there a program? Was there a teacher? Did someone show it to you, or did you find it yourself?
I found it myself. My father was big into sports. So I got into
Mm,
sports. I got into batting averages and shooting percentages and, football touchdowns are worth 6 plus 1 for the extra point. So I got into math pretty quick and it resonated with me. And some people, it just didn't click. Um, and it just resonated with me. It was a love of mine. And then I learned that, hey, I can use this to make a career out of it. So wasn't sure what I wanted to go to school to study. And
mm,
I found out about electrical engineering and RF communications. And I focused in my undergrad on RF comms. And then Hughes Network Systems came interviewing. So I went down and worked
mm.
for Hughes, and they introduced me to the world of space. And it sort of took off there, no pun intended. I've been in space for 25 years now.
Wow.
I've never really coded. I've never really designed chips, but I've always been
Mm,
in the problem solving. We as engineers,
mm.
we want to solve problems.
Yep.
So I studied double E, electrical engineering. I've been in the satellite industry for 25 years. I've continued that learning through a number of ways, but we engineers like to solve problems, and some engineers like to work with others to solve problems, which is what I like to do. So I went immediately
Yeah.
into the business side of things.
Nice.
I've worked my way through post-sales support, into sales engineering, into product development and management,
Mm,
and then into marketing and biz dev. So I sort of worked my way back, if you will. So
mm.
I had to take those 24/7 support calls in the middle of the night.
Uh-huh.
So now, as a product developer, as a marketer, and as a biz dev person, I know what's on the other end of the line, if you will.
Oh, that's such a beautiful thing to hear you say, because
Hmm.
in my day job I work in its support side of things as well, and
Hmm.
I've done some pre-sales, post-sales in technology,
Yeah.
um, and having someone that understands that, who's because the marketing side of things, biz dev is you're bringing the business in,
Hmm.
right, and taking what I guess depending on I don't know how it looks in satellite, but in tech it's kind of this is where we want to be, this is the
Hmm.
thing we're trying to sell you, and then bring you down the line. Having someone that understands that is I think a beautiful combination in a company.
Yeah, I think the whole sales engineering solution architect role is really where the magic happens,
Mm,
because they're engineers, but they also have a sales mind to them, and that's sort of where I come up through. So yeah, I did the post sales
interesting.
support, spent a lot of time implementing networks and making sure that
Mm,
those work, satellite networks, troubleshooting all sorts of things, including trees in front of antennas, and
wow.
those are tough to solve. So you got to move the antenna, not the tree.
Mm,
And then moving into sales engineering and putting solving customer problems that they know they have and problems that they will have that they don't
mm,
know they have, while being responsible for the technical design, but also the commercial design and the commercial engineering around it. And that's sort of where the rubber hits the road.
mm,
And then I got upstream into product management, product development, and now as biz dev marketing, market dev, if you will, talking the language and solving
mm.
problems. There's a lot of engineering out there for engineering's sake, but if you can't solve problems and make money out of it, then what's the point,
Yep.
right?
I love that. No, that's a side. It's interesting because just because someone's an engineer or good at engineering does not mean they'll be good at the sales side of things.
Exactly right.
It's definitely a personality type, a type of person, um, and skill set, honestly. So that's cool. That's good to know. Um, what brought you to Ramon Space?
So similar from the sales cycle back, I've worked
Mm.
satellite ground equipments. I've made tried to make those work. I've made those work. I've flown satellites. So I spent a long time at Intelsat flying 53 some satellites and trying to fill
Wow.
those up. I did service providing. I provided services, meaning you choose the best satellite, you choose the best ground equipment, and you do
Mm.
services. And then I
Oh.
thought to myself, well, why don't I start building satellites? So I was over at Thales for 3 years, building satellites that would be either at GEO, MEO, or LEO, and we can get into the orbits,
Yeah.
geosynchronous, medium Earth orbit, and low Earth orbit.
Absolutely.
And I saw a definite need in the industry. Um, we are rocket scientists here in our industry, but most of the science is in the rockets. So
Mm.
we've done a lot of things to push forward and push the envelope in rocket science and getting us to space. We haven't spent as much time focusing on what we do once we get there,
Yeah.
meaning what we're focused on here is taking Earth-like computing to space.
Mm.
So as opposed to just getting there, we're a very hardware-driven industry. The satellite industry and the space industry is. What we're trying to do, and the need and the value proposition I saw here at Ramon.Space is we're taking software to the skies. So
Mm.
using Earth-like thought processes, but applying those to space. And it's not as
Mm.
easy as taking something commercial off the shelf and then just flying it in space. There's a lot of things to consider,
Yeah.
including the environment. But I saw a definite. It's cool engineering. As an engineer, that was cool.
Mm.
But having had to make money with satellite and spacecrafts, having them
Mm.
be less intelligent perhaps than maybe they could be,
Mm.
I saw the definite need, and I was excited to come over and head up the commercial efforts here. So everybody that I've talked to, our story has really resonated with them as well. So it's an exciting time to be here.
Absolutely. We've had the opportunity to talk to a few people in this idea, and it's opened my mind up to number one, the need of supercomputing in space, and I've been on this kick of what do the first 50 to 100 years of humans really living in space, not on the ISS, but off the ISS and
Mhm.
elsewhere. What does that look like, and what kind of computing power is going to need to be brought with them? Because like if you're talking about the moon or even more dire the Mars, like
Mhm.
it's a you need to bring everything with you, and it needs to work, and it needs to it needs to be able to be, I guess, good enough for the entire trip. So in the that's big picture of what I'm thinking about.
Mhm.
So that's
Yeah.
exciting.
A good example of that is The Martian, right?
Yes.
With one individual left behind, and he
Hmm.
has to make his way and navigate life and grow his own crops
Mm.
and find his own water and fertilize those crops. And the communication to Mars you saw was very archaic
Yeah.
with the time lapse of minutes.
Yeah.
And one of the, you look at the basic human needs, water,
Hmm.
food, shelter, communication back to Earth,
Yeah.
communication to each other. So there's a lot of structure, if you will, a lot of elements that need to be considered before we go to the moon and stay a while, before we
Right.
colonize Mars. So to just snap a finger and say, okay, I'm going to order 50 servers and send them to Mars, that's not going to work. But
Fair.
engineering from
True.
the ground up and providing the right technology that can do that is the proper route.
Mm. And it feels like we're at this unique point where space is seeing this, almost 10 years of this initial push towards more progress, more money getting involved, people kind of coming back from the shuttle era. Um, it seems like there's a huge infrastructure need that's, if even if we wanted the progress to happen tomorrow,
Mhm.
it's not there yet, and it seems
Right.
like there's a good amount of work ahead, and it seems like Ramon.Space is going to be trying to solve a lot of those problems.
Yeah, we're going to need computing. We're going to need structures. We're going to need 3D printing. We're going to need the ability to transform something into water.
Mm,
Hopefully, we don't have to transport that. We can find it in space somewhere.
right.
There's a lot of science that can only be done in a vacuum. So, doing science in a vacuum, setting up those capabilities. And then there's keeping humans safe, not
Mm,
having a 2001 HAL unit that says, nope,
right.
sorry, can't do that.
Yeah. Yeah.
Keeping people safe, allowing them to communicate.
Mm,
And a lot of it comes to, what can we do on Earth? We can we can work with and the standards bodies are already looking at this. So
mm,
considering satellite and space as part of a hybrid network, fitting
mm,
satellite into hybrid technologies with the latencies and the jitters that are incorporated here on Earth.
mm,
The latency and the jitters are going to be completely different as we go to space. So from the ground up, building something that works in space is going to be key. It's not a
mm,
case where we can just take what we have here on Earth and put it into space. So it takes
right.
folks that have flight proven technology, that have done this in the past, and
Mm,
understand the challenges of space.
oh, absolutely. So having gone to school for aerospace engineering, I heard flight proven technology a lot,
Mhm.
and it was pre SpaceX, so there was a little bit of the confusion of like, well, okay, if how do you get something flight proven if there's really not an opening and there really wasn't a business case in those
Mhm.
years for brand new things. It was, hey, just fly the thing that works.
Mhm.
How do you guys get to the point where you're flight proven? I know you guys have was over 50 missions. You guys have
Mhm.
flown. What how did you get there? What have you tested out? Where are you at now?
Yeah, so I'll talk about the missions first, and then the
Mm,
economics and the ease of getting to space, which has really lowered the bar, if you will, to get demo units, to get flight proven, to get technology onto spacecrafts. But we've done a number of things. We've jumped on asteroids in the past. The Hayabusa 2, our technology jumped on an asteroid there
that's awesome.
to find out, and it's still on the asteroid too, which is pretty cool.
Oh, that is
As
cool.
as an engineer, I tell my son that, and he's like, "Oh, that's cool, Dad."
That's sick.
We're orbiting Mars, so we're taking pictures of Mars. We're gathering information to send it back. We have gone closer to the sun than anybody else.
Mm,
And this is working with agencies. So in the past, we worked with
nice.
agencies. We're controlling instruments. We're taking pictures. We're compressing that. We're sending it back to Earth to be evaluated. And I'll talk a little bit about the need for remote analytics.
Mm,
We're going to Jupiter, so we're going to be rotating around Jupiter. It's going to take 8 years to get there. It's a tough
wow.
neighborhood radiation wise,
Mm,
so that's going to be a
that's a good
challenge.
test. Yeah.
That is going to be a good test, and that was delayed a little bit, but it'll
Mm,
get there
yeah.
eventually. Um, and another just a simple one is the Cygnus mission from
Mm,
NASA. So the
yes.
reflection of GPS signals can actually tell you the and it was neat to learn this, the speed and the direction of hurricanes and tides and shifts.
Oh,
So the
wow.
ability to multi-purpose a spacecraft and gather that data. So you mentioned the number 50. Our technology has been on a number of missions. We've had 0 failures. So only with a
That's
purpose
awesome.
built from the ground up solution can you do that. And we're moving
Mm,
into leveraging that know-how, that expertise into more of a commercial play, working with the
mhm.
commercial folks. So back to the point of how do you get flight proven? Hats off to Elon. Hats off to those in the launch industry. There's new launch companies being birthed every month, it seems
Does
like.
it's
So
true.
access to space has gotten much easier, much more
Mm,
economical. Um, but space means a lot of things.
mm,
It means communications at LEO is much different than communications at GEO.
mm.
And MEO is a rough neighborhood radiation wise. So you need to harden, I think it's like 10 times to go to GEO, 10 more times to go to MEO. You need
Wow.
to make sure that your spacecraft, the entire spacecraft, and the part of the spacecraft that we do is very key. We're the brain or the hearts, depending upon how you want to look at it.
Right.
So if you launch something for, let's say at LEO, you launch it for 5 years,
Mm,
and for some reason you're using off the shelf product that conks out in 2.5 years, you've just lost 2.5 years of revenue. Or if you take a GeoBird, which is even worse, back in the day when I was launching GeoBirds, I had to have a crystal ball looking 18 years out because it took 3 or 4 years to launch. And
wow.
then it was up there for 15 years. And it
Mm,
was very difficult to use an old satellite that was designed for one geography and take it to another geography. So, and as your mobility market changed and the fixed market came up, and then the backhauling market would fall off and the mobility market would come back, and then oil and you get the picture. So
yeah.
it could be consumer, there's a changing markets, and nothing designed today will be serving the same market in what is it, 2022, 2037. So
Right.
the ability to be dynamic in how you allocate your resources, one, you need to last for 15 years. And two, the ability to dynamically allocate the supply. And in our industry, the supply is not the spacecraft, it's not the computing, it's the spectrum. So, what we
Mm,
as an industry need to do is most intelligently as possible use our spectrum and allocate it and use smart physics to focus it in the right areas.
very cool. I am kind of blown away by how, I mean, it's silly to say, but space is really complicated. There's so much going on.
Mhm.
And, with that lowered bar for access to space, now we're also talking about drastically increasing the amount of space debris, space communications that are out there,
Mhm.
and if it's not done in a smart way,
Mhm.
it's gonna be a complete disaster. Um,
Space,
so,
space situational awareness
mm,
is very important. So what we're going to need is more autonomous systems that that can work with each other and make sure that they they social distance up there,
right.
but also social distance with others, so that
Mm,
we're not, because we are a chain, we as an industry are a chain reaction waiting to happen. So we need to take more caution and more concern with our awareness when we're up there. And at the end of the day, we do three things: we store data, we compute data, and we connect data.
right.
So the three of those are being done in different ways. And there's not a standard, if you will, that one constellation works with another, but there needs to be a more intelligent, more autonomous sort of ecosystem, if you will, in
Right.
space.
Yeah, absolutely. And I guess who decides that? Is that the industry adopts certain standards and then that becomes the norm? Is that still something that's being figured out?
Still something that's figured out. I
Mm,
mean, people say that they're sustainable in space. I'm not sure that there's a formal definition of that. I think we all have a different definition of that. There's folks that take more care and caution in making sure that they are a proper citizen in space versus others. So
yeah.
there are concerns, both physically and spectrally, to make sure that everybody works in harmony. And there are some traffic cops, if you will, no pun
Mm,
intended, that make sure that everybody is transmitting, receiving on the same levels. But even then, there are games you can play to get around those. So
Sure.
it's becoming more complex. It's getting more crowded. The advantage of the democratization of space is there's many more avenues to get to space. The negative is the
Mm,
same. There's many more avenues to space, so you may get some players up there that aren't as cautious or
mm.
play won't play as well with others.
Sure. Yeah, and it's interesting the whole long-term scope. You mentioned like 18 years in orbit.
Mhm,
Um, Also having like contingency plans for what if things don't go well and you have to do orbit. Like SpaceX just lost, what was it, 40 Starlink satellites
mhm,
from an EMF. Like that's
mhm,
that's bound to happen. It's
mhm,
inevitable. It's the environment. Um, yeah, how do you guys think about things like that? I saw I was looking through your
mhm.
website, radiation shielding. What are the different types of applications that you guys do that makes you guys unique to the industry?
Yeah, so back to the three things: store, compute, and move. Right.
Yeah.
So one, storage is becoming key. So storing data, especially for low Earth orbit satellites that aren't always within view of their gateways. So they basically take a
Mm.
large scan, they store that data, they wait until they're over the gateways, and then they have a
Right.
number of minutes to dump it, if you will. So
Mm.
it's growing in scale, the amount of storage that's needed, but the amount of compute is even more important. So if you can make, and I'll get back to the collision avoidance, which you were talking about here in a
Sure.
second, but if you could make more decisions on that data locally, one, you could compress that data, you could filter out that data, and you're increasing the amount of good data, quote unquote, good data that you're storing before you get over your gateways. So edge
Mm.
computing, edge processing, intelligent decisions, artificial intelligence, machine learning. Those are important applications that are going to increase the efficiency while keeping the spacecraft the size that they need to be. And then connection. So connecting that data and making sure that the beams are focused in the right area,
Mm.
that the all satellites are a function of size, weight, and power. So how big are you? How big do you need to be? The weight is a function of launch cost. So how many
Mm.
kgs do you need to get up there? And
Right.
then power draw. And power becomes uh, 99% of the issue when
Yeah.
you're in space.
Mm.
Um, my experience there is with solar panels, they do fail over time,
Mm.
and you need graceful degradation of a satellite. You don't need it. You need it to gracefully degrade, and then you can take the phrase graceful degradation to a constellation. So more decision
Mm.
making that a satellite is out of orbit. Uh-oh, I shouldn't be here, so I better deorbit now, and that's already
Mm.
programmed into their into their intelligence, right? So the
Right.
more intelligence, the more capabilities, and the ability to upload new code onto satellites are going to be key,
Mm.
because once you
Mm.
launch a satellite, you don't want it to be there for 5, 7, 10, 15 years without the ability to reprogram it,
Mm.
both from a commercial standpoint, but also from an emergency standpoint or a contingency standpoint. So
Mm.
we're really focused on reprogrammable Earth-like computing to store, move, and connect folks at either LEO, MEO, or GEO.
Oh, that's wild. That's a whole nother level. I in college was lucky enough to be in a project where we worked on a 3U stack CubeSat.
Mhm,
The idea was to take solar weather readings, monitor the sun, and it was a fascinating project. Like the power management was such a huge part of it that when you don't work on it, you don't realize it, and it's pretty crazy. But even like the computing power we could have had on that tiny thing
mhm.
compared to today, that's 2012. So it's a huge difference in what's out there now.
And
Um,
computers draw a lot of power.
mm,
So they draw a lot of power. So designing it purpose built with the lowest power draw possible, we're creating a new figure of merit in this industry. It's the amount of power, the amount of computing per power, per watt.
mm,
So if you are drawing less power, then you need less, a smaller array of solar panels, if you will, and the longer the satellite's going to last. So if you can
mm,
imagine, commercially, you launch a satellite that you think is going to last for 5 years, and it lasts for 7, 8, 9 years. Well, it's all profit at that point.
right.
Your cost is sunk. you have some OpEx, but the OpEx of flying satellites is very small, especially in a constellation compared to the actual cost of the birds. So
Oh,
if you can
interesting.
extend that, it's all profit. One, you need
Hmm.
to get it to a certain point where you make your money back on the constellation or the satellite, and then everything after that is all fill rate. The more you can fill
Hmm.
up a bird, and it comes down to pre-commits. I'm getting too commercial for the your tech audience here, but every engineering, every good engineering solution has a very um, impactful commercial elements. So
Hmm.
having to had to make money or lose money on spacecraft in the past, that's very core to my being.
Hmm. No, absolutely. I mean, it's the business side of things. That's I think a lot of people who work in STEM or want to work in STEM don't realize like it would be great for science to work in a vacuum and we didn't have to worry about
Mhm,
the business side of things. But at the same time, like that's what helps push this stuff.
mhm.
So it's important to think about things like that.
And there's a humanitarian element too, right? We're
Mm,
bettering the human condition by learning about the solar system. And I
mm.
learned recently that 50% of the climate change parameters can only be seen from space, and the other
Oh wow.
50% can be enhanced from space. So we are bettering the condition, and I won't get into the debate whether we should go to space to better the human condition or better our own human condition here on Earth, but
Yeah.
we're doing both. And it's also neat to know that you're using engineering, STEM, for something good. We're bettering the human condition. We're learning
Mm,
about ourselves. We're learning about our place in the solar system, and also what's going on here on Earth, our home.
absolutely. Um, Collision detection in
Mhm.
space. Let's head back to that. What are some of the things that you guys are doing in that kind of regard?
First of all, you need to be autonomous amongst yourself and make sure
Mm,
that you're where you should be. Reporting back down to Earth to those that monitor and keep track of where you are. So, the ability to report that back, and the ability to be intelligent enough to incorporate different data flows.
mm,
So we are a space. We are the satellite industry. We use satellites, but we use a lot of data, and big
mm,
data is getting bigger. Big data is getting bigger exponentially. The ability to process that data, use that data intelligently, and make real time decisions is going to be key.
mm,
So we need to know that, hey, something's getting close to us, right? Or
mm,
there is an event that we've seen. So be on the lookout. So it's not only the spacecraft themselves that need to make decisions. It's those that fly the spacecraft. It's the Earth stations. It's the ground stations. It's
mm,
the terrestrial network tied into the satellite network.
mm,
And once we make satellites invisible in a hybrid network, then we've really made it. We then, the satellite industry, the connectivity industry, is pretty small compared to the overall telecommunications industry.
mm,
Now, you'll see a lot of spectrum plays here with 3G and 5G, the ability to roam from ground into space, the
mm,
ability to grow for S-band, for instance, both in scale and scope. But the ability of a spacecraft to fluently um, speak to a hybrid network is going to be key, and the standards bodies are helping there, but we as an industry need to make sure that we keep the pressure on. So collision avoidance is something that we cannot avoid, no pun intended, right? And we
yep.
need to design in our spacecraft, in our brains, and in our space hearts, if you will, the ability to
Mm.
to avoid.
Yeah, oh, absolutely. It's that problem's gonna happen so quickly too.
Mhm,
I mean, literally, I think I've seen SpaceX launch 4 times in the last month, and that's just one company.
mhm,
Um, so it's that's coming. That's coming for us, whether we're ready for it or not. So it's good to hear that you guys are working on that stuff.
mhm.
Um, what are some specifics? So you guys are thinking of. Um, Actually, let me ask this question first because I have you here to throw this idea off of. So I, I'm a little. I don't quite know. We've got the delay of time between places right now for data to go back and forth. Um, is that a problem that can be solved? Like you were mentioning, the Martian is that
Mhm.
delay. Is there something that can be done, like we've done, like with the repeaters for um, the subsurface cabling in the ocean, right? For all that stuff. Is there
Mhm.
any way around that? Is that a software solution?
The delay is tough to work with. I mean, we're
Mm,
working with the speed of light, so
right.
I haven't come up with a something faster than the speed of light, and if so, that'll be my own company, and you'll be hearing about that soon.
Absolutely.
But we are limited by the speed of light. We're
Mm,
limited by physics, gains, and losses along the way,
right.
attenuation, things like that. So there are repeaters possible, but what we should focus on is what we can do remotely versus having to be done here on Earth. Now, in the case of the
Right.
Martian, uh, they weren't anticipating an individual having to live off the grounds there, so their comm system wasn't quite there.
Mm,
But we could, in theory, moving forward, 50 to 100 years in the future, have a network on Mars, have a network on the
mm,
moon, and I know folks are trying to do that. So there are limits to the speed of light and physics that we can't overcome, but we can do other things intelligently. As we as an industry
right.
have done that, we started with spoofing. So a geosatellite takes about a quarter of a second to go up to a geosatellite and down. There are some chatty protocols that just doesn't work with. So if you
Mm,
can spoof it locally and pretend that a unit is talking to a server, and then just take care of it on the link and spoof on
mm.
the other side, then you can open up and you can unthrottle a link, if you will. So
Ah,
that's a very
that's
basic
cool.
way of opening up a pipe, as opposed
Mm,
to having to wait for a handshake, go back and forth for every time. If you can
right.
spoof that locally, and that is with old school X25, SDLC protocols, some IP protocols as well.
Mm,
So there's similar fashions here too. So what decisions can we push out, and that's going to require reprogrammable units. So something we
right.
sent, it takes 8 years to get to Jupiter. We're not sending a technician up there to fix it.
Right.
So you're not getting software uploads. So whatever you send is pretty
Mm,
much going to be in operation for 8, 10, 20 years.
right.
So there are intelligent things we can do, but unfortunately we're still limited by the laws of us physics.
Well, it shows the sheer scale of what we're working with in space. You know,
Mhm.
it's so far that the speed of light becomes variable depending on the location, or the amount of time, I should say.
Mhm.
Um, so when I love the idea of reprogrammable units that you're launching into space, and a thought came to me. Tell me if I'm on the right note here,
Mhm.
but you've got you've got satellites you can send up. Let's say over time you wanted to increase the bandwidth, the speed that you're sending that data on those passes. Um, it's a interesting problem because of the power needs. Where like something on Earth, you kind of are like, hey, if I can get power, I can make this as powerful as I need to. I don't have to worry about making it efficient.
Mhm.
I'm sure there's a whole art to thinking about a science to thinking about how to do that the right way, especially when you guys have your own units. You've got a special um, way that you guys can tweak that other people can't.
Mhm. Yeah, there's two things there. One is maintaining power through the life of the satellite,
Mm,
whether it be 5, 10, 15 years. So one, low power draw is key. Intelligent power draw is even more key. Satellites
mm,
at LEO and MEO aren't always on. So they can turn off at certain points, and then they have duty cycles where they rev up their batteries and they don't use their batteries to transmit 24 hours a day. So you can be more intelligent in how you do that.
mm,
With some spacecraft, you can't change the functionality of those spacecraft. We talk about applications. If I was to look back 15 years ago and figure out what applications are important now, I would have been wrong. And
mm,
if one says what's going to be important in 2035, you're wrong. You don't know. But
yeah.
if you have the ability to fully reprogram your spacecraft, your processing, your use of the supply we talked about before, which is the
Sure.
spectrum teamed with power on the bird, then you can adapt and you can be resilient to applications you don't know about yet. And that was the big
Mm,
fear back in the day when we were launching GeoBirds. A new application comes up 5 years into a 15-year life. Well, we can't support that.
right.
Or I'm just going to use a geographic region. Africa was hot, but now it's not so hot, but we need it in
Mm.
Indonesia. But the beam for Africa is not sized for the beam of Indonesia. So you
Oh
sort of
wow.
twist it, but you don't have the right cities covered and the right areas covered. So
Mm.
you need the intelligence and the ability to reprogram on many levels. It could be from a data processing level, but also on a software defined radio radiation level. The ability to take that spectrum and channelize it and put it in different channels over 15 years. And hopefully you can last for 16, 17, 18 years, and then you can put it into inclined orbit, which
Mm.
extends the life 10 times. So there's a lot of things that reprogrammable units enable you to do. It removes the fear that your spacecraft is going to be not useless, but less useful 5 years from now, even less useful 10 years from now. So reprogrammable payloads,
Mm.
the ability to be dynamic and to change to market needs is key.
Yeah, absolutely. And thinking about that as a from a commercial standpoint, that your flexibility of your investment is now, I mean, it's a totally different investment than it was 10 years ago, 20 years ago.
That's
Um,
exactly right. Your business
mm,
plans are completely different now. You have less risk in the plan, which means you can take more commercial risks upfront, and your profile of not hitting your numbers is much lower if you have an intelligent payload. If you have something that's hardware based, that's fixed on a broadcast application, for instance, and that's where the connectivity business came up. You send something
mm,
from New York, a broadcaster will send from New York, and then it's downloaded into all the cable head ends, thousands of cable head ends. You send it once, it's received many times. So a
mm,
satellite doesn't need to be intelligent when you do that.
right.
So one, linear TV, my kids don't watch linear TV. They're always streaming.
Yeah.
So linear TV is going down. I only watch it for sports,
Yeah.
or the news occasionally, but you can get your news online as well.
True.
So linear TV is decreasing. But the challenge with broadcast TV is if you need to send to 10 people, it's the same economics as sending it to 10,000 people. 10 million people from a
Oh.
spectrum perspective, because you're
Mm,
sending it up from New York, for instance, and it's coming down throughout the US,
mm.
Canada, Hawaii, Alaska. So there is a transition, and there is a flattening of demand, if you will, for that bent pipe connectivity, which is why you're seeing more software defined satellites, which is why you're seeing, and then you bring down the orbits to MEO and LEO. The main advantage of LEO is the decreased latency, the ability to decrease the
Oh.
latency. It's not a quarter second, it's much quicker. And that's a big push. But with
Okay.
LEO, you're so close to Earth that you can't cover a lot of Earth. So you need hundreds
Ah,
or
okay.
thousands of satellites. So the economics are different than MEO, which is sort of like a Goldilocks, if you will.
Mm,
GEO covers a third of the world. The old Arthur C. Clarke put 3 satellites up and cover the world.
yep.
MEO is closer, so it's a little bit better on latency, but it covers a much bigger area.
Mm,
And LEO is even smaller. So it covers a much smaller portion of Earth. So you need handovers, you need beamforming, you need a lot more technology on those. But the economics, the CapEx requirements are much different as well.
mm. It's amazing the spectrum of not only opportunities but like applications just per orbit uh, are now being accessible more than they've ever been before.
Mhm.
So like all the different types of companies are going to pop out that are going to need this stuff. It seems like yeah, the sky's the limit. No pun intended. It's not. Uh, yeah. Are there any other applications we haven't touched on that are unique to you guys?
The applications, we're seeing a lot more need of edge computing. So
Mm,
computing on the edge, making decisions, data centers in space. So the sovereignty of space, the ability to store data or connect data centers in space. We're seeing a lot of as I mentioned before, the challenge with Leo birds is you have a very limited footprint. So
mm,
the ability to downlink only in locations you want to downlink is are key.
mm.
So the ability to, for instance, download only in Five Eyes countries and not into other areas. That's becoming keys.
Oh, yeah.
Having the intelligence to do that. Um, Other things that we do is gathering insights out of data. So what I mentioned
Mm,
before is big data is getting bigger. and people are buying, we've moved from mapping the world to gathering insights, tying in social media feeds, tying it all together and creating insights and tasking these satellites autonomously, as opposed to somebody who is, the old telephone operator that's connecting the different, take a scan of this, take a scan of that. And current day events show just how important the ability to see data, whether it be without clouds or through the clouds with radar, for instance, and make decisions based on that data quickly and not have to wait for hours, minutes, things like that. And that comes back to revisit rate. So if you're mapping the world, you only need to revisit it maybe once a week, once a month.
Right.
But if you're gathering movement of something or the height of grain barrels or something like that, you want to gather that multiple times a day. And that becomes more important than simply just looking at pixels.
Yeah, the amount of data that we want is, we have so much data here on Earth that, yeah, space is only catching up at this point.
Mhm.
That's wild. That's wild to think about how things are going to change. And with everything that's going on today, I mean, what was once stable can, tomorrow change. So the ability of you guys to be able to reprogram
Mhm.
on the fly is, this launch independence, now payload independence,
Mhm.
and being able to adapt when things change on Earth.
Mhm.
It's becoming more and more important.
Yeah, intelligence has a lot of levels. I mean, from a satellite manufacturer level, how can I be more intelligent with my resource power?
Hmm.
From a satellite as a service perspective, you're seeing some folks launch apartment buildings in space, if you will.
Hmm.
Give me a payload and I'll launch 5 at a time. But the ability to again allocate that power, making sure that everything works coherently, making sure that everybody gets the resources that they're signed up for, and proving to those folks that they're getting the resources they signed up for.
Hmm.
That becomes key. Then you have the folks that sell the insights themselves
Hmm.
and analyzing the data in flight, making decisions in flight, and then tying it all together. And it's different from LEO to MEO to GEO. And the approach we've taken is we're vertically integrated. We design our own chips, use our own silicon.
Love
We
that.
incorporate that into systems. We are not commercial off the shelf Earth um, equipment, which does a couple things. One, it ensures the duration of life of the satellite.
Hmm.
There could be failures of non-space grade equipment that is flown, and two, we're more powerful. We draw less power. We're more powerful, but allowed to draw less power. So we draw less power, physical power, but our computing is much more powerful, and our decision making is much more robust.
Hmm. I love that. Let's see. We had the March 15th release of this. Is there anything that we haven't touched on this release? Did you want to go over that a little bit right now?
No, we've really staffed up over the past 6 months. I joined about 4 months ago. We're incorporating our technology, our know-how, our engineering, our radiation hardened techniques into systems. So what
Hmm.
we're launching here at the satellite show, right before the satellite show, is the first of those three things I mentioned: storage. So the ability to store data, to store a lot of data, to store it
Hmm.
with the right radiation hardening to make sure that there are no failures in flight. Again, you can't send up a repairman to fix it.
Right.
But it's all part of a platform. So once you store data, then you can also compute that data. You can compute before you store, and you
Hmm.
can connect. So intelligent connections. So it's part of an overall platform. We have a family of products. This is going to be the first. We're ready to on launch that to launch that around the satellite show. There's definite use cases. We'll be doing some demos there on the booth.
Awesome.
And it's the first of many. So, and what's interesting is we use the same base platform, base technology to do all three. So, if you will,
Oh
you
wow.
could store, compute, and process. And we have a family of products, a family of hardware, a family of software, but it all works together very gracefully.
Mm.
And it provides the ability to do all three at the same time. But the first product we'll be launching formally is our new stream product. And that is going to be the storage product, streaming data onto a storage device, if you will.
Mm.
And it's part of that moving Earth-like computing into space.
Yeah.
And one of the issues that we're addressing is moving Earth-like storage capabilities there for really data-intensive applications that are
Mm.
going to be needed. We talked about space technology and all of that, and space is hard. Space is hard, tough environments. So the folks that we're working with really can't compromise performance, and we're really pushing the limits in a good way in terms of size, weight, and power. And sometimes I like to flip that and say power, weight, and size, because
Mm.
everything's getting smaller. The weight is a function of every kg costs money to launch. That's a one-time cost.
Right.
The long term is the power. How much power are you drawing of that finite amount of resource that you have on the spacecraft? So
Mm.
we're very excited by it. We have a lot of interest. Our calendar is full. Our demo booth is going to be full, and
That's
it's the
awesome.
first product of many that we'll be launching.
That's incredible to hear. What kind of do you have numbers to share on the storage capacity? I'm just like fascinated by how does that relate to, I guess, in a real weird way, like your phone. Like, how much storage are we talking here?
We'll be starting with 1 terabyte, 2 terabyte, growing up to eight
Nice.
terabytes, 16 and beyond. So uh, it's no joke.
Yeah.
We believe that big data is getting bigger. We're designing for 5 years from now, not designing today.
Love
Some
that.
of our customers are saying, "Well, we don't need that much," and we're like, "Just wait, you
Yeah.
will, you
That's
will."
yeah. I say that every time I get a hard drive. I just have to buy an
Uh,
18 terabyte one because it's just
mhm.
never enough.
That's right.
So I hear you. How does that compare to what's readily available right now? I know one of the missions I was seeing recently was like 250 gigabytes. I think that's
Mhm,
what New Horizons went with
mhm.
to Pluto.
There's different applications, and I don't like to quote other storage.
Sure.
We believe that ours is north of that. We believe that we're one thing we're doing is we're preparing for the future too.
Yeah.
So a storage device could be a compute device, could be a connectivity device later. So the
Mm.
ability to provide software, we as an industry need to move space from a hardware business to a software business. And that's the game changer that we're bringing to this. We're
Mm.
not a hardware. We talk about terabytes of storage, but we can do so much more than storage.
Mm.
We'll be talking about later in the year our compute product, the ability to compute, to do artificial intelligence, machine learning, the ability to open it up to anybody that wants to write code. In theory, can write code, and my code could be on a bird, on a
That's
satellite, on a
amazing.
constellation. So it opens open. It's exciting as an engineer, right? As a
Yes.
young engineer, it'd be very cool to say my code is riding on that satellite or those satellites. So the ability to offer that service to users is very cool, and we want to enable that. And back to why RamonSpace. That's one of the reasons why I came over here.
That's beautiful. I'm really starting to understand why. I think you guys are doing some great stuff. So, you're looking to bring in some more people to
Mhm.
expand. What kind of, I guess, a message for anyone that's interested? What kind of a place is Ramon.Space? What are the people like?
Mhm.
Tell us a little bit about that. What are you guys looking for?
It's a unique mix. The satellite industry usually has satellite people, and it's a
Mm.
very small industry. We all know each other. We've all bought from, sold to, competed with, or teamed with everybody else. Ramon's taking a little bit different view. We come from the storage background. We come from the earth. Come from the earth. We use earth-like computing techniques. Um,
Mm.
we have investors. Our board members are legends in the storage industry. So bringing that new thinking into space has been very, very interesting.
Mm.
So we're bringing on more space people, folks that have background on incorporating payloads into spacecraft. Those that have tried to make money on the service provider side, like myself, and the satellite operator side. Those that have worked with the big primes that have built large multi-hundred million dollar satellites
Mm,
or multi-billion-dollar constellations
mm,
that understand the problems to be solved.
mm,
Um, but it's a very fresh way of thinking.
mm,
And we're a small organization that's doing big things, and we'll be growing very quickly over this year and next. And anybody that wants to, the next frontier is space. I would say it's computing in space because
mm.
we've gotten there. We're not ready to go further until we build the layers of computing out for us to go further into the solar system. So
Right.
for any young folks interested in STEM that are looking forward and think space is cool. One, it is. Space is hard. There are a lot of problems to be solved,
Mm,
and new problems come up every day. So it's thinking outside the box, literally.
mm,
It's working in a vacuum, literally, but working within an ecosystem at the same time. So,
mm.
um, yeah, big things are happening.
That's amazing. So Ramon.Space, for anyone that wants to check out the website.
Mhm.
You guys are going to be at the which satellite show?
Satellite 2022. So it's
Nice.
in Washington, D.C. So we're going to have a big team there, number of strategic meetings. It really is going to be a big show for us.
I'm excited for you guys. I'll be looking out for any kind of posts or stuff. Do you guys post on social media at all? Is
Mhm.
there anywhere else people can follow along?
Yep, we're on the Twitter and
Beautiful.
we're on LinkedIn. So you can get updates from us there. We provide updates on our website. We did a good blog. We did a blog, which I'll leave it to the audience whether it's good. But we focused on software empowered satellites because
Mm,
we as an industry need to move beyond software defined to software empowered because
mm,
software is not a thing in itself. It's a thing that enables other things. So, and the
mm.
ability to update that software, it's always changing. So you could launch something that is software defined, but if you can't change it, then what's the point? We're looking
Yeah.
at software empowered,
Mm,
empowering somebody to do something different, empowering somebody to launch something without knowing what is in the future. If you're future built
got it.
and future proof, people don't like that phrase, but if you're future built, let's stick to that.
Mm,
You don't need to be afraid of the new application that's going to be here 3, 4, 5 years from now because you can reprogram, because you can change the allocation of power,
mm,
because you can change where the beams are, beams of one, if you will,
right.
over particular users. So
Mm.
only purpose built, but with the ability to be flexible solutions are going to work moving forward.
That's a beautiful thing to think about. Launching a mission and having the ability to adapt the mission along the way. I mean, that
Mhm.
seems almost sci-fi in like we've seen it in non-technical sense in like Star Trek and stuff like that, where they're able to adapt along the way.
Mhm.
Um, but to think that we're not only is there a monetary value to that, there's a scientific value to that too, which I think is understated. Um,
Mhm.
at least at the first as I'm learning this. So, Steve, thank you so much for joining us. Do you have any last thoughts for folks?
No, I just think that I appreciate you having me. It was a pleasure to be on here and look back 25, 30 years on why I got into space. I appreciate the questions. We're really focused on the next frontier and pushing things forward, taking Earth-like computing to space. But as people look at what's available out there, I think that the fact that we're vertically integrated, we do our own silicon, we're doing it from the ground up. It's purpose built yet flexible. I think that's really key, and that's what turned me onto it. And the value proposition, I think, speaks for itself. The business problems we're solving are real, and they're different depending upon orbit, whether we're going to deep space again, and what the customers are trying to do. But there's there's an interesting shift happening in the industry here, and we're happy to be pushing that envelope.
Well, you heard it here, folks. Steve, good. Thank you so much for joining us in the podcast and sharing your story. I was honored to hear from someone who's had 25 years experience in this. Is you've been around. You've I'm sure at this point, like, is it more like an art? Like, you just there's some things they come naturally to you because you've just been around it so long.
Yeah, I mean, I've worked for a lot of companies. Actually, I worked
Mm.
for two companies twice, so I don't
Oh
piss
wow.
anybody off. Sorry.
No,
Um,
no. That's important. That's important for people to hear
but
if they
it
get
is
into
a
STEM.
it is a tight industry. So
Yeah.
having worked on the ground, in the air, service provisioning, building satellites, like I said, we are a small industry. We're bringing in new thinking, and
Mm.
we can only take it forward. I look back, when I decided to get into the space industry, it's very tough to leave the space industry
Mm.
because there's a lot of opportunity here,
Mm.
and space is cool again. Space wasn't
Yeah,
cool there for a while.
it's
But
true.
thanks to the privatization and money being flown into it, space tourism is going to be huge, or at least people are talking about it being huge,
Yeah.
and making sure that humans are safe once they get there. Those are exponentially more challenging than making sure that satellites remain alive for 15 years.
Mm.
Right. So there's a lot of challenges to be had, but we as an industry will get there. It's just going to take some thinking outside the box, some
Mm.
leveraging new technologies, but and also not forcing it. So
Mm.
if you can't force one solution into a certain set of problems, and I personally have tried to do that, and I've failed at it. So there's a lot of scars and a lot of gray hair on this head from doing that, but it is a small industry, and we all think space is cool,
Mm.
and we welcome the next generation to come in. I know that part of your audience are those in STEM. We welcome new ideas. We welcome um, different perspectives into the industry. So it's a good place to be.
Awesome. Well, thanks, Steve. I don't want to take any more of your time. Thank you for joining us and telling us more about Ramon.Space. Um, thank you, everyone, for listening and for being a part of this episode. Don't forget to check out Ramon.Space and everything that they're doing. Spread love, spread science, live long and prosper, and we'll see you next time for another episode of Today in Space.